welcome to the show. It's me, John Park, and this is John Park's Workshop. Look, my hair's all shiny. New product? I don't know why. So yeah, here I am in the workshop, and it is time for another John Park's Workshop where we'll get together and build some stuff and talk about some things and maybe go over some projects, past and present and future. As you can probably tell, I'm in front of my retroreflective green screen because I'm so excited about the retroreflective green screen and I had it set up, so why not? And actually I think it might be kind of a cool way to show some work I'm doing today inside of a CAD program without having to do sort of pictures in pictures. I'm going to do a bit of an overlay and see how that goes. And I also want to say, hey, thanks for coming by and watching this show. To everyone who's over in YouTube and Discord, I'm watching those chats. I will not be watching the chats over in Twitch and Periscope and LinkedIn and Twitter and all those places. It's just too much. But if you want to get in on the chat, head to Discord. It's adafruit.it/discord. And I can take some questions in these chats, however. Also take a comment. I just found out my mic level was a little low, so thank you, C. Grover, for pointing that out. I'm going to boost that a little bit. Hopefully that'll sound good. Virtual Lars. Yeah, I think that's him right there. One question I see, Saltima asks over in the YouTube chat, will he talk about the reflective fabric screen? Yeah, I will. I actually wanted to go over a couple things about that. I know this was a project from last week, but since last week I've put out a Learn Guide. I wanted to go over a little bit of info in there that I added, as well as the design of the device that clamps the LED ring to your camera. Hey, I'm just noticing, since some lighting changed, I gotta fix my chroma key. Let's see if I can fix this without breaking too much. That's a little better. There we go. I was seeing some little buzzy bits there. So we'll get into that, though, I promise. Before we do, however, let me take care of some business. Here's a bit of business. Did you know that we have a jobs board? Yeah, that's right. There it is. That's the Adafruit jobs board, and you can... here, let me do it this way. What's a good way to do this? Is this a good way? How about that? Sure, I like that. I'm going to be messing around with camera views today. Sorry, I apologize in advance. So this is the jobs board. If you go to jobs.adafruit.com, you will see we have a free job board with positions that are looking to be filled, as well as people posting their resumes and info. So head on over there if you're looking for work or if you're looking to hire someone. It's entirely free. All you need is an Adafruit login, an email login, and once you're in, you're in. So if you want to look for some work or if you want to hire someone, you can head over here. Here's some positions right here that you can see on the board, as well as the little UI there where you can post a job, view the jobs. If you're an employer, you can go to your little dashboard. We can browse skills offered. Look what happens when I click on that. Then we see some people looking for work and some of their info there. What type of, we have a lot of embedded people, engineers, developers, software developers, art and design, lots of good skills on offer there. So that's the job board. It's at jobs.adafruit.com, and I recommend that you go check it out. All right. Next thing I wanted to mention is I have a product pick of the week show that I do on Tuesdays. It looks something like that. The look of it changes every week as I get to have fun tapping my inner weird creative vision. And on the show this week was this AW9523, which is a 16-pin input-output I/O expander for digital in and digital out, as well as you can use those pins as 16 constant current LED drivers. And I'll give you a little recap of the show. Here we go. AW9523, 16-pin GPIO expander on I2C, and LED drivers that use constant current. 16 pins arrayed around the top and the bottom. There's, I think, 11 on the top and 5 on the bottom there. And all those pins are in pairs because they each have that V-in for the voltage. 16 little 3mm red LEDs plugged into the board, and as you can see, I'm doing some different little fades and lighting them in some sequences, turning them on and off. Right now they're getting brighter, 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 and then they'll drop down. Use the little stemma QT connectors. You can plug in up to 4 of these on one microcontroller, and then you'd be able to run buttons, LEDs galore. That's the product pick of the week this week. And by the way, I think that that product is in use on an upcoming project from Liz Clark and the Ruiz brothers, which is the MIDI fighter that they're making, kind of like a MIDI lover, they said. They're lovers, not fighters. But it's a 16-button, arcade button clip launcher for things like Ableton Live. And it's got arcade buttons that are lighted, and I believe they used that I/O expander to do the LED driving in that. I'm not sure. They may have used it for the buttons as well. I haven't checked out I don't know if the guide's out yet, but it's close. So go look for that. Let's see, what's next? I wanted to take, okay, so some questions about the retroreflective screen here. So I'm using it right now. If I turn off my LED ring, you can see this is what I'm standing in front of. So this is the retroreflective fabric. And when I turn on my LED ring, it's lighting that screen really saturated, really brightly with green. Not lighting me with green, however, which is one of the nice things about it. And it's like I've said before, it's fantastic because usually in a very small space like this, in a closed space, these kinds of shadows that I've got some key lights on me, these kinds of shadows cause a problem with a fabric green screen or a painted green screen, so you end up needing to light the background separately from the subject, and it's really difficult in a small space. So I wanted to show, I had mentioned this last time, but I wanted to show some images from the guide. So let me pull up, first of all, turn this back on here. I'm gonna pull up my Learn guide for this. Let's jump over to the Chroma Key Essentials, and let me smallin myself here. Look, there's small me. Yeah, that's pretty good. So this is the guide. If you head to learn.adafruit.com, you'll see it in the new guides section. I've got some little sample videos there. And if you take a look at the Chroma Key Essentials page here, I talk a little bit about some traditional chroma key, so green screen and blue screen. And here's some examples of some different traditional green screen effects. So this is actually a musical that was done by my son's high school. Here's my son with his puppet. This is the alpha channel that I've pulled, or the mat that I've pulled using that green screen. That's traditional green screen. And you'll notice that green screen has some hot spots there where I've got side lighting. I'll show you what that looks like in a second. But I've lit him from angles that are sufficient to keep him from casting too much of a shadow on the backdrop. You can see his shadow on the ground there, which works out okay. So this shows the shot on the green screen. This is after I've done the offline composite pull of the green screen using a plugin inside of Premiere is where I did it, but most applications can do this sort of thing. And this is what that looks like with just the subject and no background. And then this is the final composite in this apartment that was done for the show. If you take a look here, this is pretty much the setup we used, although I was doing that first set of shooting in his bedroom. This is actually in a larger space in the living room. And you can see I've got to use up a lot of space there in order to get the subject closer to the camera and not casting shadows. And so like I've said, this backdrop I'm on here, I'm right up against it. So you can imagine it's great for small spaces. It's also great for this type of thing if you're doing conference calls, or if you're streaming, if you're doing live streaming of games, let's say, and you want to do a chroma key, this retroreflective background is pretty great for that. Now, some other stuff I go into here is some particulars about the way this retroreflector works. I linked to a couple videos, or a video at least, in the Scotch Light from 3M website, which talk a little bit, and there's some diagrams and things about how this particular fabric works. It's got thousands and thousands of tiny glass beads, which act as refractors. So a beam of light, even if it's coming at an angle oblique to the surface, it is refracted towards a reflector, like a mirror-like surface, and then re-refracted right back at the viewing angle. So that's kind of the magic of retroreflector. It can also be done with box reflectors, which are 3 corners of mirror-like surfaces. That's what's in like a traditional reflector on a bicycle. Anyway, lots of good info about retroreflectors. Here's a little demo I do using this ring light, pointing it at a reflective screen, and then compositing the skull over there in front of Lady Ada there back in New York. And then the other thing I wanted to talk about was this mount that I built. I didn't have this last week, or I had like an early version of it. So I designed this. Let me go down shooter actually on this so you can see it well. So I designed this so that it will attach to a wide variety of lenses on a camera that uses external lenses. And so the way I've done this is with these 4 adjuster blocks that just grip the lens from the side, the barrel of the lens. And then I have a silicone band here as an elastic band or rubber band to pull those tight. So you can see, you just kind of grip those, put them over the lens, and then let them squeeze in. And it does a pretty good job. You can, of course, do things like having a threaded adapter, like a filter adapter that you could screw this into, but that would be for a particular lens, and then you might need step-down adapters to deal with other lenses. So I just wanted to go for something that would work on a couple of different lenses that I'm using. And this will work pretty well even on things like, let me bring back up the guide here for a moment. This will work pretty well with external webcams. So here you can see this is the build. This is it on one of my cameras. Got some details of putting it together. Here's the 3D model I built. And then way down here at the bottom, you'll see this is one of these C90 or C920 webcams from Logitech. And you can see there I've got it adapted to that pretty well. The 4 little adjusters, I've got it turned 45 degrees, but using 2 of those elastics, I've got it stuck there pretty well. It's not coming off. And then if you're just using like a laptop lid, you might be able to just hook these blocks onto that, depending on the thickness there, or adapt it otherwise. Use a clothespin. There's a lot of ways you can get on there. Rubber bands and so on. So that's the follow-up I wanted to do on that. One other thing I wanted to do actually is kind of a fun trick with this, is that since it's this magical retroreflective material that works at pretty much any angle until we're getting close to glancing angles, you can move it. So I'm grabbing and moving the fabric, and until it self-occludes, until I cover itself with itself and block the light, I can move this around. So you essentially have this sort of invisibility cloak type of thing here, where we can block things. And unlike a traditional green screen, even though there's a bunch of little self shadows and stuff here, it's not causing a problem. Up here you're seeing the back side of the fabric actually. So it's inexpensive stuff. You could cut a hole in it and do all kinds of fun tricks. They make clothes with this. They make accessories. So it's available, which is terrific. Someone commented yesterday that they saw the guide I had put out. I think it was Adam Wolf said, saw the guide and figured, oh, that's cute. It's probably really pricey for that material. And then he looked online and it was like $9 for a yard of 39-inch wide material. So it's pretty inexpensive. All right, I think that's gonna do it for my recap of some of that green screen info. Yes, Saltima says, when is Adafruit selling this fabric? That's a good question, actually. I think Lady Ada is kind of excited about it and was talking last night about getting some for her setup that she uses when she does the Desk of Lady Ada. She uses a green screen. So maybe they'll get excited and order some. That'd be nice, because right now I've mostly found it's an eBay seller kind of thing. It's not really easily available to the public. It's not like 3M markets and sells this along with their command hooks and things like that. So it's a kind of a harder to find thing, but not bad. You can look on eBay. I think I've seen some resellers on Amazon as well. All right, yeah, John Park's Workshop is hidden behind John Park's Workshop. It's true. It's kind of, well, it's not too much different back there. It's just a different angle of the same place, which is absurd, and I like it. Let's see. Next up, what are we going to talk about? So I want to launch a new project. So let's go back to the downshooter here for a second, and that ought to work right there. We can see it that way. So what I have here is one of our brand new Feather RP2040. So it's the RP2040 chip, the same thing that Raspberry Pi built and put into their Pico boards. So we have a Feather that has that chip on it. And right now I have it plugged into one of these 3.5-inch TFT touchscreen displays. It's a resistive touchscreen display. And you can see here I've got some mock-up code running right now where when I press, oh, what just happened? My camera just disappeared. Oh, oh boy, that's pretty funny. It's actually live right now and working as a camera switcher, so I just switched away from my camera. Yeah, that's funny. Okay, I can't really do that without it disappearing every time. But you'll see now. I'll just fight the thing and press it in software. So you'll see right now the second cam B is lit up. I'm going to press that first button, and now it's switched to cam A. And if I hit C, it'll go to cam C, and that's actually the one we're supposed to be on. So if I press that, I should be able to, yeah, press that back. I've kind of given away, what am I doing with this thing? I want to create a camera switcher with it. You've seen I've built these before out of things like little mechanical keyboard button boxes and arcade button boxes, but I kind of like the idea of having that sort of Stream Deck. If you've ever seen, there's a product called a Stream Deck by Elgato, which is used by a lot of streamers and gamers, as well as other people who just like to have a very versatile button box, macro switcher box. And what the idea here is we're going to have some buttons with little icons, maybe 4 across and 3 down, maybe fewer, probably not more because it's not a huge screen. And we'll be able to create icons for those so that I can do things like switch between camera views, change audio sources, bring in graphics, as well as have it switch into a mode where it just becomes an entirely different set of keys for something like Photoshop shortcuts, or if you're using music software, or if you're using some CAD software. And in fact, let me jump back to my browser window here for a second, and I'll just show you the kind of thing I'm talking about. Stream Deck. I'll just bring up an image of it. So it's these kinds of things, right? So these they come in different sizes. Oh, here's a cute little 3x2 one. I kind of like that one. And so these have essentially a screen. There's a single screen. It's not a bunch of little LCD or OLED buttons. It's actually one screen underneath a layer that has clear buttons. And I'm not sure if they're capacitive or resistive touch. I'm sure people have done teardowns of these. But you can change the graphics, which is really just one big graphic, and then it has sort of little hotspots for the touch, so that it associates a button with a graphic and then sends a command. So that's the idea behind what I want to build here with this thing. And a couple notes about this. So this is this TFT that has a resistive touch screen. And I just started playing around with the basic libraries for it last night to get this much working, but I'm having some issues with it, so we're actually calling in a ringer. And you may know Foamy Guy from our community, who does a lot of work in CircuitPython. Foamy Guy is going to help me out and co-develop this project with me, do a lot of the hard work, which is great. And there are he's very versed in some of the display I/O things, text things. So I think this is going to really be a sort of premier project when we're all done with it. Oh, Oh, Hugo mentions Lady Ada has done a teardown of the Stream Deck. That's cool. So the idea behind this, I think, so Todd's saying I should call it the Stream Park. I think I want to call it the Touch Deck, but thanks, Todd. So I'm thinking maybe of doing a 3D printed or laser cut overlay that kind of cuts out our physical button space so that it's a little easier to hit the right things and not, you know, accidentally fat finger it over to the sides. I don't think I'll bother with like the acrylic buttons. I think it'll be enough to just have sort of a little grill or grid that we touch it through. And what I wanted to do is show you how I'll go about building the case for this. Johnny Bergdahl just jokingly / rudely says, Foamy does all the hard work, John is just the pretty face. Yes. No, actually, so what I wanted to show today is some of the hard work that I'll be doing is building a case for it, designing sort of an enclosure and a stand for it. And the way I go about this is not necessarily the way you'll go about it, but because I think a lot of people should be using something like Fusion 360 for this. But as you've seen before, I like to use Rhino. It's a piece of software I'm really familiar with. And so what I wanted to do was show you sort of the beginnings of how I'll work out some of the dimensions and model for this, starting from the product itself. So there's a few options here. I'm going to move my camera up closer. So there's a few options here for getting started. You could go ahead and, sorry, I'm going to focus this camera real quick, if it'll let me. You could go ahead and, here we go, grab the Eagle files that we have published. So there's a board file, and you could grab that and maybe export DXFs to get started. That works great. Sometimes, however, you'll find there's hardware that does not have a published file for it. So what I'll generally do is grab my calipers. So I've got some nice digital calipers here, but even really inexpensive digital calipers would work great for this. And what I'll typically do is go in and take some dimensions. And so I'm going to do some of this in real time here. Some of it we'll talk about and not do because the show would go too long otherwise. But what I'll do is I've zeroed this out and I'm working in millimeters, and I'll say, okay, this is 85.5 millimeters by 55.66. And actually, I like to write those down as I go because I will immediately forget them even before typing them in. Or I'll take one dimension and type it in. So I've just got a notebook here. So let's redo those. So vertical, I've got, we'll call it 56. And I'm calling that vertical and this horizontal, just because the orientation we're going to use. And we'll call this 85.6. And then what I'll also do is right now I'm going to figure out these holes here, these mounting holes, because those are going to be important. So again, I like to zero this out to make sure we're getting a good measurement, and then I'll go in with the calipers here and grab that hole, which is about 3 millimeters. So I've got 3 millimeter holes, and they are in these little cutouts, which are 5.2, 5.15, 5.15, and I can figure out the thickness of this a number of different ways. What I'll do is just find from one edge to the other edge of that hole the size there. I've got 83 point, we'll call it 83 point, well, I'll just grab that, 83.29, 83.3. Is from hole outside to hole outside. What did I say that was? I should not talk after I write a number down. 83, no, 83, 83.3. Okay, 83.3. Okay, so that's actually more dimensions than I'd normally take before I start building stuff, just because I want to see it as I do it. So, couple things. So Rhino, I actually, I've used it a long time. I haven't used Grasshopper very long. Grasshopper is a module inside of Rhino, and I haven't used it in a while. I need to relearn Grasshopper. Grasshopper is the sort of add-on to Rhino that turns it into more of a procedural tool. Otherwise, Rhino doesn't really have a history that you can go and like redimension things after the fact, which is why I say most people don't want to use this. It's expensive. It's commercial software. You can get away with some free CAD, Tinkercad, or Fusion 360. Really, probably what you should be using. But I'm going to show you how I do it in here, because some of the things I do will apply. So I have a scene here. The working units are millimeters, which is what I like to work in. I'm just going to rough out that those first dimensions. So it doesn't matter where I make this. I like to kind of start on a grid, but not the origin. So I'm going to set down a point, and then Rhino's real friendly for just typing things in. So it wants to know 2 points. I'm going to type in 85.6, which was the width of it, and 56, which is the height of it. And now I have my box. So if this were Fusion 360, you would lock in those dimensions, and then you could go and change them later for a different board and do a lot of great procedural stuff. I'm not going to be doing that. Now I'm going to get my these little ear guys here. Actually, I didn't take the height of that there, which matters, and it's 66 millimeters apart there. So I'm going to write that down. 66. And sometimes I'll just set in some dimension lines for myself. Like if I just make a 66 millimeter long line right now, and I can snap its midpoint to the midpoint of the other object. Now I have sort of a line I can inference some things from, which is helpful. And you can go and kind of create these sorts of construction lines if you want. So I know that my intersection point for the top of this little dog ear is going to be here. And in fact, I'll build it that way. A lot of this is kind of can vary just depending on what I'm feeling, how I'm feeling like doing it. So the sort of width I said was 5.3. So I'm just going to make a duplicate of this that's 5.3 millimeters that away. And so I can go ahead and grab a copy of that and head this way. What did I say, 5.6 millimeters? No, 5.13. Okay. And I can get rid of these little dimension-y guys. Oops. Get rid of these. There we go. So that represents the top of those little dog ears, and I said I have a 3 millimeter circle there, so I'm going to go ahead and create a 2-point circle. Again, I'll just type in 3 for 3 millimeter. I can take this, and again, I can center it on that hole. I think it's centered on that hole, but that's actually something I should measure in a moment. And I want to center it between these guys. I don't have a line here, and now I do. And I can take this and start to move it, and as I move it, I can sort of project from its center. Let me turn off the grid snapping here for a second. I'm going to grab a center snap for you, and then I'm locking going in this direction, but for a moment I'm going to grab that midpoint, and now it'll give me an intersection of those. So now that's centered there. One more thing I'll do at this point is radius these, and actually I've never come up with a great way to measure the radius with calipers, so some of this is going to be a little eyeballish. I'll kind of go to the corner, and it looks like it's about 1 millimeter. So I'll try making a 1 millimeter radius or fillet here. So I can just type in fillet, and the radius is already set to 1, so I'll pick here and here. No, that's definitely not it. All right, let's try 3. It might be 3 because of the size of that circle. That would make sense. You and you. You and... No, that's a little too much, so didn't like it. So you can see here again, I don't mean to... I love Rhino. I don't mean to bash it too much, but this as you can imagine, if you were doing this in Fusion or something, you would probably have a little slider to go in and start adjusting that radius by eye. I could go in and measure some things. Here, let's do 2.5. And this actually doesn't matter too much for what I'm doing because I'm just using this as sort of a, there we go, as sort of an indicator of how I'm going to build the rest of the design. So now what I'll do is I'm going to duplicate that, and I'll just type in mirror, which has tab completion. I'll go and mirror a set there. I'll go and mirror a set either from the center or the midpoint. Cool. Last thing I'll do is make this into one nice curve with a curve Boolean, which just sort of joins them up into a single curve so I don't have pieces and parts flying around everywhere. Oh, I forgot to tell it to delete the stuff I don't need, so let me undo that and redo that curve Boolean. Grab everyone, repeat curve Boolean, tell the options to delete everything that's involved. Do that again. So if you're not familiar, I keep talking about things like Fusion 360 and procedural or parametric modeling. Essentially, each step that I'm doing here, you can kind of think of as something that if you had a history of doing it, you could go backward and forward through the history. That's what I should be doing using Grasshopper in here. That's what you'd be doing inside of Fusion 360. And it would allow me to go back and say, oh, you know what, I want those circles to be 5 millimeter for whatever reason, and the things that are dependent on that would update. So if I redo this sort of thing, maybe I'll do it in Grasshopper sometime for you, then I would be essentially building nodes of data that flow through operations. And the beginning thing would be some dimensions, telling some lines to get constructed, telling a circle to get constructed, telling some lines to chop each other up and join together, and so on. So each of those are nodes with data that can flow from one node to the next. All right, so what I like to do at this point is create a 3D model from the 2D so that I can visualize the thing. So right now, essentially all I'm making is a stand-in for this, but that I can extract lines from what I do so that I know where I'm going to put the parts of the model or screws and nuts so that I can build the thing up. Construction of it may end up being somewhat similar in a lot of regards to this thing I built, in that it's going to be a three-dimensional, 3D printed thing with maybe some parts that are connected using screws. It's a technique I like to use, and it's fairly straightforward to do, and allows you to not create difficult to print stuff. So one of my goals is to make the printing part easy, so if things need to go together, they get screwed together typically. So what I'll do with these is I'll actually extrude all these curves, and the height of this thing will make it, it's probably like a 1.5 millimeter board, and then I'll put the screen on top of it. So yeah, let's do 1.5 millimeters, and again, you'll have to pardon me. I have some old-fashioned ways of doing stuff here. I'm sure there's better ways that any Rhino people are looking at going, why do you do it that way? I'm just going to extrude those circles a little extra bit and cap them. I'll show you this in a shaded view. I'll cap this. And then I'm just going to Boolean, which means either join or cut out or intersect. There's different Boolean operations, but I'm just going to say a Boolean difference, which is going to allow me to chop these holes out of here. Again, you can do things like sort of pseudo proceduralism, where you save copies of things in your different layers. So right now I haven't worked with layers in here, but if I went back a step and put the cutters, the things that are cutting out, on one layer and the object that's getting cut out on another, duplicate that, I can kind of keep all those pieces and parts, and it's helpful if you're going back a little bit, but not in the same way as a procedural creation. So that's the board. I should probably save at this point, just in case something bad happens. I'll do TD01. And Then the dimensions on the screen, so the screen is actually edge to edge right over the PCB, so that's easy. I'll just check its depth here with the calipers, and it's a 4.6 millimeters. So kind of go back to this top view here. I can create a box corner to corner. That's kind of an easy way to do this. So I'll just go to, let me turn off the center snap. So I'm going to say right there to, and you can see I'm kind of pausing over things that I want to project these inference lines from. And then the last dimension, while I'm creating it, I've just created the width and height, or width and height. Now I need to create the depth. For that one, I'm just going to type in the value that I just said, so 4.6. And so that's my screen sitting on top. And now what I'll do is if I want to create a stand for this thing, maybe I'll play around with the angles that's going to be built at. So one thing you can do is, we'll go to a nice rendered view here for a second. We can take our object here and sort of start rotating it up. Nice thing, the render view puts a shadow wherever the floor is, so it's easy to see stuff sort of in 3D space. You can just type in values, so if I say, you know what, I think I want this at like a 33-degree angle. Great, that's what I'm going to use, 33 or 45 or whatever it is. And of course you can make a stand that does graduated steps with little things to click out or onto, but I think I'll just make kind of a solid thing. Similar in a lot of ways to this type of stand that the Ruiz brothers made that I have a mag tag sitting on. I kind of like that type of design. So let's go back to a top view here. If I'm doing that, what I'll do is probably I'm going to take these models and put them on their own layer now. What did I say? Did I put those on layer 1? Let's put them on layer 1. So now you'll see I've got my models sitting on their own layer. I'm leaving these curves here. I'll actually build a layer for those. And usually you'll name your layers so you can maintain some organization of what you've put together. So here you can see I've got a different color for that layer. Here on layer 2, one thing I can do is maybe I like that shape and I want to keep that sort of dog ear shape. Maybe I want to build something that this sets right into. So basing the next step on those same lines that I built the board from, that's kind of why I do that, why I put that board in there. I think what I'll do here is, again, I like to create something based on some of the existing geometry. So I'll go in and snap to some points. I can eyeball, I can measure, I probably do something like this, and then I'll snap that. So I'm going to turn on center snapping, and now I should be able to snap this to the points that exist in the model already. So midpoint. Boop. So this is now going to be sort of the thing I screw the device into, but I've got some stuff on the back to worry about, right? So at this point, I'll save you. I'll spare you from me measuring that, but I'll pretend I went in. I think these are actually 2 inch by 1 inch. And one thing that's nice is that you can work in multiple units in here. So I will verify that actually before I make that. So let's look. The width of that is 0.9 by 2. And there's a little extra space there for some other stuff. But if I wanted to build, let's say, a 1 inch by 2 inch box to chop out of there, or curve to Boolean there, again, I'll just start a curve kind of anywhere, and then I'll move it in place. And so I'm going to say 2, but I'm going to type in quotes for inches, and then 1. Oops, I got to hit enter, and 1. So that's going to be cut out for my feather. And then I should really measure. I don't know if it's on the center of this thing or not. I should measure how far that is from each edge. So from the top, what I'm calling the top edge, that is 0.6. So again, a lot of different ways you could work. I like to here's one way I like to do it is to just sort of snap it up to the top edge of this, and then I'll move it negative point, I think it was actually 0.7 inches. So now I've dropped it down. And this is going to be a cutout, so I want it to be a little bigger than the object, so this way the feather just kind of hangs out the back there, so I can go and do a little sculpting like that. And then I'm going to take these two curves and do that curve Boolean again. I said I'm going to pick these two curves, do a curve Boolean, there we go. Good, so now I have something that I can extrude into maybe a 3 millimeter thick object, so that covers both acrylic, if it's going to be a laser cut thing, I use 3 millimeter acrylic a lot, or a 3D printed thing that's thick enough to not get super bendy but not take too long to print. We can go in and round some corners, so I can do it all kind of at once. I can say fillet corners. The radius it's asking for, I'm going to just do like a universal, how about 3 millimeter? Or what were these guys, 2.5? Let's do that everywhere. I like consistency. See, now you can see my curve has some nice little roundiness to it. And I'll go ahead and extrude this. So let's go to a perspective view where it's a little easier to see what's going on. I can hide this. Let's put this guy on his own layer. So we'll move you back up to the default layer. A lot of what I do with this is just layer management. And we'll hide that one for a moment. We'll turn back on the model I made just to kind of get a reality check against the model. That looks pretty good. And we'll go ahead and extrude it down that way. It's just so we don't have to move it as much. Extrude curve, say -3, boop. And this one, I don't need to carve stuff out of it, so I can just cap it immediately. And then I'll go to a right view. And this one doesn't need to be snapped perfectly because these are not objects that are being modeled together. One is going to get screwed into the other one, so having a little space there is fine. Or you could do some snapping, but it's I don't find that to be vital in this case. So again, let's take the whole thing and rotate it up just to. Oops, I missed a part. Again, this is just for looking at its sake. Looks pretty good, looks pretty cool. And so if this is going to be, let me undo that. If this is going to be a sort of all-in-one printed piece like this and not have moving parts or connectors, there's probably an angle that can't go beyond without being difficult to print, but I'll try it. I'll try it at this magical 33 degree angle I was thinking about. So let's take, we can take all this stuff, and we'll do the 33 degree angle, rotate on that. Let me hide this top curve, and I'll move the piece that I'm keeping to a different layer. Let's put you on layer 4 is not used. Okay, so now I'm not looking at that curve hanging out there. Let's go to shaded view. That just shows us some of our pieces and parts. Oh, I do not want these false colors on here, so I'm just going to set everything to black, which gives us black lines and a tannish, grayish surface. I no longer like that angle, actually. So let's take all this. Let's go. Let's see. Another. If I want to go to 45, I want another 12 degrees. Oops, not 23. 12. Okay, I'm liking that better. And let's lift that up just to get it above the origin there, which makes it a little easier when you're looking at a grid view. Okay, I kind of like that. Let's do that. So I haven't really thought too much about how I want the stand to look from here, but I think it might be fun to do, let's see how much time we have. It might be fun to do the stand screws on a couple legs, like a little triangular leg set, instead of trying to print one 3D thing. It actually then could be fairly straightforward to make it with other methods if it's not a weird 3D shape. Or you could do both. So I'll leave space for both of those options. And the way I'll do that is I'm going to come into this right view here. Let's hide the, I really should start naming stuff. Let's hide the model of the TFT display. And now this is the stand base that we're working with. And what I'll do is I'll start, again, creating construction lines. So I'm just going to make some curves that I can use to sort of visualize things, right? So that's parts of my base. And if I move those, again, I'm going to put those onto their own layer. Let's see, is anything on the default layer at this point? I don't think so. Maybe, oh yeah, just that one curve, that's okay. I'm gonna set that active layer so things I do happen on that layer. We can also lock layers and make them semi-see-through and stuff. But what I want to do is create the intersection of these points. So let's turn that off. So I just want to yet another line that's going to connect the dots. Cool. And again, I can either slice stuff or do a curved Boolean. I'll do that. Curved Boolean just makes my triangle. Could have just drawn a triangle and had those points, but that's not how I went about it. And then if I bring back my model layer for a second, we can see I'm going to want some width on these legs that allows the holes to get screwed through. So let's or just attach it. So let's bring in, let's look at everything at once now. I'm going to go to top view here. I'll snap this to the existing model. Get a little closer there. So now it's snapped to the intersection. And so, you know, like I've said, Rhino is interesting. It's got a lot of it's very handcrafted, hands-on type of thing. It allows for a lot of creative decision making as you go of how you want to build stuff, what you want to snap stuff to. It's very, I use it in kind of a straight ahead manner. Often that bites me because then I need to go back some steps when I don't like something, but that's kind of the nature of it. And again, I hope I'm not doing Rhino a disservice if there's better ways of working that other people use, but this is how I do it. So now what I'll do is I'm going to make a duplicate of that, let's say, and maybe I can do a cool thing here because I got a request from someone about making things like boxes. So what I'm going to do is I'm actually going to extrude a little surface of those. You could loft these two surfaces or just, I'll do that. I'll just loft between these two surfaces or these two curves to create a surface. That's good. Oh, what's it doing? Why is it thinking? Is it asking me something? Uh-oh. Oh, it's over there. Sorry. Yes, I like the default loft options. It popped up a window I didn't see. So what I can do is I can cap this, and we can either carve some holes through there, Boolean out some circles. We can make little indents. There was a command I was going to use, and now I'm blanking on it because it's fairly new to me. What the heck is it called? Oh, darn, I should have prepped for this because there's a cool new way I learned that I hadn't used to create sort of a semi-hollowed box. What is it called? It is shelling, maybe. Let's try that. So I'm just going to type in shell. That's one of the nice things about Rhino is that all the interface, you can just type stuff. You don't need to know where things are. You can even just guess at words and it kind of auto-completes. Select faces to remove from closed poly surface. Yeah, I think that'll work. So if I wanted to make like little carved out sections, I don't know why, but I'm going to do it right here, let's say. I can set the thickness of walls. So let's make, again, let's do 3mm thickness. Oops, 3. Done. And so you can see it created a nice, it's not like I carved out, it's not like I had to measure 3mm back from the wall and do offsets. You can't normally scale things uniformly when you're trying to do this sort of thing. So I'm glad I remembered it because that's a really handy new feature, especially for making things like boxes. I used this technique on the keyboard model that I built recently. Oh, you know what? I'm sorry, I haven't checked the chat. Let's see. C. Grover says, perhaps a mounting bracket for haptic feedback motor. Oh, that'd be really cool. Yeah, having like a little buzz would be great. So some legs would be nice. Yeah, so that's where we're at now. Sorry, yeah, sorry I didn't look at the chat. I got deep into what I was doing there. So at this point, let's say we're going to do something like this. I might want to merge these models into one and try 3D printing that, probably face down and let the triangles come up from there. I could also do these screw holes. So that's the last thing I'm going to do here. I think it's the last thing we'll have time for. If we want, we can take some circles. So what I'm going to do is I'll just create some new circles let's do some cylinders. I'm going to do some cylinders. Will they let me? No, I'll do circles and then extrude them. So I can set a circle, even though things are kind of not planar right now. Let's see, it should let me find the center. It might not. Let me go down here and look at this one. I'll do this one actually. Let's take this curve. We could have made that as a cylinder. And now we'll do a cap on that. What I'll do is I'll move this by picking the move command, picking the center of this cylinder, head up to the center of this circle. It's not liking that at all. Come on, you know what I'm trying to, there we go. And let's go to wireframe so we can see that, or we can ghost it. Oh, you know what? I have planar turned on. It's not going to let me, is it? All right. I wish I had done this a different way. Sorry about that. So let's see. I'll try extracting that curve instead. Go up to curves. Curve from object, duplicate edge. I'll pick an edge, duplicate it, and let's see if I can extrude that. There we go. I'll turn shading back on. And yeah, I don't have, this is not a great way to do it because I don't actually have that that angle. It's not going to want to slide along that angle. So pretend I did this right and left this on the ground and went back. I'm just going to bring this down here. And let's actually, you know what, we'll go through all of these. So let's do, yeah, this is a terrible way to do this because I don't actually have the ability to scale it the way I want to right now either. But if, okay, that'll allow me to do it. If we want to, we could duplicate this cylinder a whole bunch of places, and then I'm going to do a Boolean difference again with just this piece. And if we look, now we have a hole that'll go through the stand and the back plate, and then we can put a screw right through the whole thing. You can imagine now too, I can kind of extract this curve and build a box out in front of it. Also do some things like drop in our little cutouts for buttons. So that's kind of a little look behind the scenes of how I approach this type of model. I will be building a guide on this, so you'll see kind of the results of the model, 3D model file, and I'll maybe do a little how-to along the way of putting it together. But that is pretty much going to do it for today. So this is sort of what it's looking like. I kind of dig it. What I'll maybe do is some iterations with this design and see, is it too tippy? Does it need to have like a bigger base? Do we need to kind of swoop this back out here a bit? How do we want to print those from sideways and bringing them in? There's a million options, but that is sort of the general approach that I'm going to take on this. So I think that's going to do it for today. I'll check back with the chat. Andy Calloway says, that would give you good vibes if we had the haptic feedback motor. Indeed. All right. Anything else? Any questions? Oh, let's see. I got a message here. Good. All right. that's done it. So let's jump back to the workshop here. Where's the big me? Hey, the big me. Thanks again for stopping by. And if you have any questions or comments, please leave them in the chat. I'll be checking the Discord. And come on by next week. I'll have another JP's Product Pick of the Week on Tuesday and a workshop on Thursday. And on the workshop show, we'll hopefully have, thanks to Foamy Guy, we'll hopefully have some software up and running that we can show off on this little gizmo. And I can do some camera switching. Probably get it to switch right now. Let's see, will that break everything? It's going to ignore me now. Okay. Yeah, it's buffering. All right. Thanks, everyone. I'm John Park for Adafruit Industries. This has been John Park's Workshop. And say goodbye to Lars. Bye, Lars. Bye-bye.